The notion of artificial intelligence, of machines capable of thought and reason, has long captivated the human imagination. From the earliest days of human history, we have been fascinated by the idea of creating machines that could think and act like us. Even in ancient myths, we find stories of artificial beings imbued with intelligence and purpose. These stories often reflect our hopes and fears about the potential of such creations. From the golem of Jewish folklore, a creature made from clay and brought to life through mystical means, to the bronze automaton, Talos of Greek mythology, who was said to protect the island of Crete, these early narratives hinted at our enduring fascination with creating artificial life. These myths were not just stories, they were reflections of our deepest desires and anxieties about the power of creation. The formal pursuit of artificial intelligence, as we understand it today, began in earnest in the mid-20th century. This was a time of great technological advancement and scientific curiosity. In 1950, British mathematician Alan Turing proposed his now famous Turing test, a benchmark for measuring machine intelligence. Turing's work laid the foundation for much of the AI research that would follow. This test, which focuses on a machine's ability to exhibit intelligent behavior indistinguishable from that of a human, challenged scientists to think about what it means to be intelligent and how we might recognize it in machines. This test remains influential to this day, serving as a touchstone for discussions about machine intelligence and the potential for machines to truly think and reason. As technology has advanced, so too has our understanding of what machines can do. Modern AI systems are capable of tasks that would have seemed like science fiction just a few decades ago. The Dartmouth Workshop of 1956, widely considered the birthplace of artificial intelligence as a field of study, brought together leading researchers to explore the possibility of creating thinking machines. This workshop was a pivotal moment in the history of AI. It was at this pivotal workshop that the term artificial intelligence was coined, marking the beginning of a new era of scientific exploration. The ideas and discussions that emerged from this workshop set the stage for decades of research and development. The researchers at Dartmouth were driven by a vision of machines that could learn, reason, and even improve themselves. They believed that by understanding the principles of human intelligence, they could replicate it in machines. This vision has guided AI research ever since, leading to the development of increasingly sophisticated algorithms and technologies. The early pioneers of AI laid the groundwork for a field that continues to push the boundaries of what is possible. From these early seeds of thought, artificial intelligence has blossomed into a vast and rapidly evolving field. Today, AI is used in a wide range of applications, from healthcare to finance to entertainment. Driven by groundbreaking research and technological advancements, AI has moved beyond the realm of science fiction to become an undeniable force in our world. The impact of AI is felt in nearly every aspect of our lives. As we continue to explore the possibilities of artificial intelligence, we are reminded of the early visions that inspired this journey. The dream of thinking machines is no longer just a dream, it is a reality that is shaping our future. The early decades of AI research were marked by a focus on symbolic AI, where computers were programmed with explicit rules and knowledge to solve problems. These systems relied heavily on human expertise to encode the rules and logic that the computer would follow. The idea was to create a machine that could mimic human reasoning by following a set of predefined instructions. This approach, while groundbreaking at the time, had its limitations. However, this approach proved limited in its ability to handle the complexity and nuance of the real world. Real-world scenarios are often unpredictable and filled with variables that are difficult to account for with static rules. As a result, symbolic AI struggled with tasks that required a deeper understanding or adaptation to new information. The rigidity of these systems meant they could not easily learn from new data or experiences, leading to frustration among users and researchers alike. A new paradigm was needed, one that would allow machines to learn from data and adapt to changing circumstances. Researchers began to explore the concept of machine learning, which promised a more flexible and dynamic approach to AI. This new direction aimed to create systems that could improve their performance over time by learning from the data they processed, rather than relying solely on human-defined rules. Enter machine learning, a revolutionary approach to AI that empowers computers to learn from experience without explicit programming. Machine learning algorithms are designed to identify patterns and make decisions based on data, allowing them to adapt and improve as they are exposed to more information. This marked a significant shift from the rule-based systems of the past, opening up new possibilities for AI applications. Instead of relying on predefined rules, machine learning algorithms analyze vast data sets, identifying patterns and making predictions based on the information they have ingested. These algorithms can handle a wide range of tasks, from recognizing images and understanding natural language to detecting fraud and making personalized recommendations. The ability to learn from data has made machine learning a powerful tool in the AI arsenal. This shift in approach has been transformative. Machine learning has enabled the development of AI systems that are more accurate, efficient, and capable of handling complex tasks. The impact of this technology is evident in various industries, from healthcare and finance to entertainment and transportation. By leveraging the power of data, machine learning is driving innovation and creating new opportunities for growth and development. With the advent of increasingly powerful computers and the availability of massive data sets, machine learning has emerged as the driving force behind many of AI's most significant achievements. The combination of advanced hardware and vast amounts of data has allowed machine learning algorithms to reach new levels of performance, enabling breakthroughs in areas such as autonomous vehicles, medical diagnostics, and predictive analytics. From image recognition and natural language processing to fraud detection and personalized recommendations, machine learning is rapidly changing the way we live, work, and interact with the world around us. These applications are becoming increasingly integrated into our daily lives, providing us with smarter, more efficient tools and services. The ability of machine learning systems to continuously learn and adapt means that their capabilities will only continue to grow, offering even greater benefits in the future. The development of machine learning algorithms has been a journey of continuous innovation. Researchers have built upon the foundational concepts of early AI to create more sophisticated and effective models. This ongoing process of refinement and improvement has led to the creation of algorithms that can tackle increasingly complex problems, pushing the boundaries of what AI can achieve. From early decision tree models to the rise of support vector machines and Bayesian networks, researchers have constantly sought new and more effective ways to enable computers to learn from data. Each advancement has brought us closer to creating AI systems that can understand and interact with the world in a more human-like way. The evolution of machine learning continues to be a dynamic and exciting field, with new discoveries and innovations on the horizon. Inspired by the intricate workings of the human brain, researchers sought to create artificial systems capable of replicating the brain's remarkable ability to process information and learn from experience. The human brain, with its billions of neurons and trillions of connections, is a marvel of biological engineering. Each neuron can connect to thousands of others, creating a complex web of communication that allows us to think, learn, and adapt. This complexity has fascinated scientists for decades, driving them to understand and replicate its functions in artificial systems. This quest led to the development of artificial neural networks, a powerful class of machine learning algorithms inspired by the structure and function of biological neurons. These networks are designed to simulate the way our brains process information, using layers of nodes to transform input data into meaningful outputs. The idea is to create a system that can learn from data, much like the human brain learns from experience. Just as the human brain relies on a vast network of interconnected neurons to process information, artificial neural networks employ layers of interconnected nodes or artificial neurons to analyze data and make predictions. These nodes are organized into layers: an input layer, one or more hidden layers, and an output layer. Each layer transforms the data in some way, allowing the network to learn complex patterns and relationships within the data. Each connection between nodes has a weight associated with it, representing the strength of the connection. These weights are adjusted during the training process, which involves feeding the network large amounts of data and allowing it to learn from its mistakes. The goal is to minimize the error in the network's predictions, which is achieved by fine-tuning the weights through a process known as backpropagation. By adjusting these weights in response to the data they receive, neural networks can learn to perform a wide range of tasks. This ability to learn and adapt makes them incredibly powerful tools for solving complex problems. From image and speech recognition to natural language processing and autonomous driving, neural networks are at the forefront of many technological advancements. The early development of neural networks in the 1950s and 1960s was met with excitement, but limitations in computing power and the availability of training data hampered progress. Researchers at the time could only dream of the computational resources we have today. Despite these challenges, the foundational work laid during this period was crucial for the future development of neural networks. However, the field experienced a resurgence in recent decades, fueled by exponential increases in computational power and the advent of big data. The availability of vast amounts of data and powerful GPUs has enabled researchers to train larger and more complex neural networks than ever before. This resurgence has led to significant breakthroughs in artificial intelligence, bringing us closer to creating machines that can truly mimic the human brain.